All right, guys, so we're going to go through the notes for 9.1 reflections really quickly here. Just to kind of start off, we're looking at the definition of a reflection. Understand that a reflection is just going to be a transformation that maps a point to its image such that we have the following, okay? And this is kind of what we're focusing on. Let's use a different color here. We're going to be looking at essentially something known as a fixed point. So if you have a point that is on the line of reflection, then what's going to end up happening is that the image and the pre-image are going to be the same point. And I'll kind of give you guys a sketch of what this looks like. So let's say I have this point A in red, okay? When I'm reflecting, okay, understand that reflections, and this is going to bring us to that second bullet point. What the second bullet point is essentially saying is that the pre-image and the image must be equidistant to that line of reflection, okay? So in this case, let's say that I'm asking you to reflect over the x-axis, okay? In this scenario, point A is 0 units away. So A prime, when I reflect it over this x-axis, it's also going to be 0 units away. So this is known as a fixed point. This is a vocabulary word that you are probably going to want to commit to memory here. And that second bullet point, I'm just going to explain it in words, more or less of what it's saying. The second bullet point is trying to communicate the fact that whenever you are performing a reflection, the pre-image must be equidistant to that line of reflection as the image, okay? And so we've got a couple of different rules. We got some coordinate notation for reflections. If I'm reflecting over the x-axis, and I'm not going to go crazy with highlighting here, but you do need to know all of these rules, okay? These rules will come in handy whenever you guys are taking a quiz or a test. So the way I remember this is if you're reflecting over the x-axis, x stays the same. So x stays the same. And then y changes signs. Now, if you reflect over the y-axis, then the y stays the same and x changes signs. Okay, so whatever axis that you're reflecting over, that's going to be the variable that stays the same. And please keep in mind the notation that we use. If you see m subscript x, then that's going to communicate that you are reflecting over the x-axis. M subscript y, reflecting over the y-axis. Next rule we're looking at here is whenever we are reflecting over the line y equals x. What ends up happening, the rule that you're essentially doing here is you're just going to swap the x and y value. And then we have the notation here, m subscript, and then that line of reflection, y equals x. Similar here, the next one we have is reflecting over the line y equals negative x. What ends up happening here is you're going to swap the x and y, and then you're going to change both signs. In my opinion, this one's probably the most difficult to remember. The other ones are pretty straightforward. So again, just make sure that you guys are committing these rules to memory. So we'll look at some examples real quick. Example 1 says the endpoints of segment AB are A2, 5 and B7, 1. It says using the coordinate rule, reflecting the x-axis, y-axis, y equals x, y equals negative x, x equals 4, graph the pre-image and image. So we'll run through this real fast. A is 2, 5. That's A. B is 7, 1. So there is our pre-image, okay? We'll say we're going to do the pre-image in, at least on my end, blue. And then the image I'll do in red. So for the first one here, we're reflecting over the x-axis, okay? Two different ways you can do this. If you're given a graph, I think the easiest way of approaching this is simply just counting. Remember, in this case, point B, the pre-image, is 1 unit away from the x-axis. So when I reflect it, if this is 1 away, then my image must also be 1 away. So that's going to give us B prime. Next, we're doing the same thing for A. If I'm going to count here, then A is going to be 5 units away. So when I reflect or flip it, then it must also be 5 units away. And if you do this correctly, reflections are going to essentially produce a mirroring effect, and we see that that's what's occurring here. And so this is our A prime. So you could also use the rules that we discussed earlier, but that would require you to plot the points, or not plot the points, but write the coordinates of the points and then apply the rule that we have. So I'll show you guys kind of what that looks like on the next one. Next one, we're reflecting over the y-axis. So this is my line of reflection. And we're working with those same points. We have A2, 5, B7, 1. Here we have A, here we have B. So if A is 2 comma 5, then A prime, which we'll do in red for consistency. Remember, if we're reflecting over the y-axis, we said that the y value stays the same and the x changes signs. So our A prime would be located at negative 2 comma 5. So just another way of doing it versus counting and using that equidistance. Next, we're looking at B. We have 7 comma 1. If we are applying that same rule that we did earlier, reflecting over the y-axis, then the y stays the same, the x changes signs. So we got negative 7 comma 1. So there's B prime. Next, we got C, reflecting over the line y equals x. For this particular problem, that line is going to essentially be our parent function. So y equals x will look approximately like this. The issue with this is you can't really count that equidistance here because the line isn't running vertical or horizontal. So for this one, let's actually use the rule. We know that A is 2 comma 5. If I'm reflecting over the line y equals x, then my rule is that the x and y swap places. This is what we looked at up here.
It's like something
so
right
our
now.
y and x will change places to become y comma x. So if I plot the pre-image here, A 2 comma 5 and B 7 comma 1, then we have the following line. Okay, and this one's going to look a little weird because I'm going over that line of reflection. So if we apply those rules, Kate, where we are essentially swapping the x and y coordinates, then A prime would essentially become 5 comma 2. B prime would become 1 comma 7. So plotting those points, we have 5 comma 2. And hopefully you're able to essentially see the mirroring effect occurring from A to A prime. Similarly here for B prime, we're going to have the point 1 comma 7, so located up here. So whenever you're reflecting over the line of reflection and your figure runs through it, it's going to look a little weird, but you should essentially still see a flip or mirroring effect happening. Okay, next we got the line y equals negative x. Y equals negative x is going to look like this. Okay, I'm just assuming that we know how to graph because we went over it a little bit yesterday. So your line of reflection should look like this. And if we're plotting our pre-image here, we had 2 comma 5 for A, 7 comma 1 for B. And then we had the transformation of reflecting over the line y equals negative x. Remember that rule, if we look at the top, y equals negative x is this rule right here, where you swap the x and y coordinates and you flip the signs. So if I look at A is 2 comma 5, B is 7 comma 1. If I apply that rule, what you're going to do is you're going to swap the x and y coordinates. So this will be A prime. Swapping the x and y coordinates, we get 5 comma 2, and then you swap the signs so they both become negative. So negative 5 comma negative 2 is A prime. Similarly here for B, to get B prime, we're going to swap the x and y coordinates, getting 1 comma 7, and flip the signs. So we got negative 1 comma negative 7 here. All right, so my lines aren't super perfect, but again, we still should see that mirroring effect happening here. And then we have our last one here, reflecting over the line x equals 4. Okay, anytime you have x equals a number, please understand this is going to be a vertical line. Something that I used when I taught algebra in the past was the acronym VUX. You have a vertical line whenever the equation is x equals a number and your slope is undefined. So if I look at the equation x equals 4, you're going to go to 4 on the x-axis, and that tells you that you're going to have a vertical line there. So we'll draw a vertical line here, and we're asked to reflect line segment AB over that line. So A is at 2 comma 5, 2 comma 5. B is at 7 comma 1. Okay, so here, because this is a vertical line, I can simply just count. I don't have a rule for reflecting over x equals 4, so we're going to use the equidistance property that we have for reflections. So A is 2 away, so when I reflect, it must also be 2 away, giving us A prime to be located here. Same with B prime. B prime is located 1, 2, 3 away, so 3 away after we perform our reflection puts B prime right here. and there would be our image. Okay. All right, next we're doing the reflections using triangle DEF. I'll probably just run through a few of these. I think that you guys kind of get the gist of it. It's more or less repeating what we did in the previous examples. So we got triangle DEF happening at 0, 2. There's D. 1, 4 for E. And then 3, 1 for F. So what we have here then essentially is reflecting over the x-axis. I'm just going to do these all on one graph, and you can just do it on the following graphs here. Just it'll be a little bit faster that way. So from reflecting over the x-axis, just count. D is 2 away, so when I reflect 2 away, would put D prime here. E is 4 away, so 4 away. F is 1 away, so 1 away when you reflect. There's our image, and we see that flip happening. You're going to essentially do the same thing with the rest of these. Like I said, I don't want to bore you guys. Some of you guys are probably working ahead at this point. If you want to check your graphs with the answer key, please feel free to check Canvas, the answer key we posted there under today's module. Okay. Once you guys finish, please feel free to work on the assignment and make sure that you are using GeniusScan to submit via Canvas. Delta Math is something still in the works, so if you don't see that assignment just yet, just hang tight. We'll talk about it more on Monday. Have a good weekend, guys, and I'll see y'all soon.